I'm David. I'm from IR Systems. I'm a field application engineer. So before I start the presentation, I just wanted to check how many of you are writing applications for embedded today. That's quite many. How many used IR at some point? Compilers? Okay, a few of you. That's good. So, the topic for today is developing secure applications with tools from IR systems. And I'll talk briefly about the solutions that we can bring into this space. I'll talk a bit in detail about code quality, security features, also show a bit of new things that we plan to release during early next year, and a bit about functional safety as well. So I put the word demo here at the end of the agenda. Maybe we don't have time to do that, but you can also find me at the Secure Things table upstairs during the breaks if you want to have a look at any of this in more detail. So, just first briefly about the company. IR Systems is a Swedish company, so I'm based in Sweden in the headquarters in Uppsala, 1 hour north of Stockholm. So IR started in the early 80s doing compilers for 8051 microcontrollers. So the first product was a C compiler for the 8051. It's still a product that we have, of course. Today, still people use 8051, but of course many use ARM. That was mentioned in the previous section here. So today we bring tools for embedded development, so not only compilers, but a lot of different things. And we have many customers, of course, globally around the world. Looking a bit more into the details, our main product is the embedded workbench. So this is a tool that is very widely used in the industry to develop embedded applications for different types of microcontrollers. So IR is typically very strong in the, let's say, from 8051 to Cortex-M architectures, as well as Renesas architectures, different microcontrollers. We do support also Cortex-A and more on the application side, but think of us as 816 or 832-bit microcontroller development tools, then that's us. So one of the key features of the embedded workbench compared to many other solutions is that you can be free to build what you want in the platform of your choice. And with that, we mean that we support many different types of devices, as well as many different types of architectures. So as we speak, I think the number is a bit higher, but as a few days ago, we supported 11,779 different types of microcontrollers with these tools. So the embedded workbench is a tool chain that integrates the compile or the build flow together with the debugger, but also a lot of other features that I'll show you during the presentation. So what's included? So I mentioned in the beginning that the IR started doing compilers. So that's very much still the core of our offering. So there are a few key reasons that customers use IR, and historically it was the compiler. Still, it's a very big part of this. So what we can provide with our compiler compared to others is that this will generate very efficient code, a very high quality code. So of course you can use other compilers and set them to optimize for different let's say if you want to have something that runs fast, you optimize for speed. You can do that with other compilers as well, but in our case, we can provide very good results, regardless if you're targeting a very small application that needs to fit in a small flash memory, or if you need it to run at very high speed. So along with this, we also have a complete set of debug tools, which includes source and disassembly level debugging, performance analysis, a lot of different things, as well as integrated profiling tools to measure the performance of your application, as well as doing analysis of code coverage, stack analysis, and many other features. To be able to work with this, you need to connect your development tools to your chip. So we provide also the hardware to do this, different types of debug probes. For normal debugging, using JTAG, serial wire output connection, or even with the instruction trace, or also in an additional one, the I-scope that you can use to measure power and visualize this on the timeline. So if I step back to this one, you have the timeline. You can see, it's maybe difficult for you to see what this is, but you can basically over time look at interrupts, call stack, power consumption, data logs, and a lot of different things. So we try to bring this value that you get from using perhaps a Cortex M7 device or something like that has a lot of debug functionality. To be able to use all that functionality, you need a debug software that can use it and display all these things for you. So that was the more general part, but digging a bit into more of the topic of this day with security. Of course, the case is that when developing for microcontrollers, still I think at least 80% of all the embedded projects are writing pure C code for this purpose. And anyone that wrote a lot of C knows that there is a lot of stupid things that you are allowed to do in C. It's not a totally perfect language. There are a lot of undefined behaviors in C, for example. So just using a C compiler does not really do everything for you. You can do a lot of stupid things, and you need other tools to possibly find these problems in your code. So how can you ensure code quality when writing C for your application? That's a good question. So of course the compiler will give you some level of details. So of course, like if you break the standard, for example, for C99, it will for sure give you an error or warnings, or even you can switch on remarks. So the compiler could say, oh, was this really wise? But then you might also need more analysis. So one key thing that we try to do here is to integrate more and more features into the embedded workbench. So bear in mind, we come from the compiler side, so maybe 20 years ago all you wanted to do was to have a text editor and a compiler, and then you ran the compile and then you're done. But today you need more and more features. So when it comes to code analysis, to make it easier for the developer that uses the embedded workbench, who sits there daily at his desktop writing his application, we added these analysis tools that can be easily run from within the tools. So you don't have to have anything additional on the side or so. So the first tool is the static analysis, which is a complete static analysis tool called CStat, which is fully integrated into the IR embedded workbench. So this tool will check for possible problems in your code according to sub-standards to C. That could be, for example, MISRA, Common Weakness Enumeration, Search C. So these are all good coding standards to use instead of only trying to conform to C. So one of the key features with CStat compared to other solutions is that you can easily have your application and just run this analysis within a few seconds. You don't have to go to a separate environment to run static analysis. You can also run it from command line, so if you have a build server or anything where you run maybe the IR compiler, you can also run CStat in the same flow. We also supply runtime analysis, so this is typically used during debug. So CStat, the first one I talked about, is a static analysis tool. So it just runs through your code. It doesn't compile it even. It just checks your code. With CRun, you build your application, you download it to your board, you run the application, and CRun has then instrumented your code, so it adds a bit of code to do some checks. So this one can then check for access to pointers that make sure that they are within the bounds, different arithmetic checks, those kind of things, and also checks for heap and memory leaks, those kind of things. So this is something that you use to instrument your code and test it on your board. And together, these two tools, the CStat and the CRun, integrated into the embedded workbench, provides a very nice and easy workflow for you to make sure that your code has good enough quality. So, going into a bit more into the details of different security things. So, the IR embedded workbench is of course not only used for IoT applications, although it's many more and more customers using it for that purpose, but we serve customers in all fields, of course. But typically for the IoT type of customers, we added a few things here quite recently. So the first thing I wanted to mention is the stack protection in the compiler. So this is in the latest release of the embedded workbench for ARM, as well as for a few other architectures as well. So the way this works is that you have an option to switch this on during compile time, and then the compiler will then decide which functions in your application that needs stack protection. So this is to protect your application against stack smash hacking attempts. So a stack smash or a stack buffer overflow, you could also name it like that, is when someone is trying to overflow the stack to manipulate the return address of the function. So with this feature, we implement this stack protection on certain functions. So if you switch it on, the compiler will decide which functions will need this protection, and if it's used, it will insert a special value, 64-bit integer, just before the return address, and then check that this is not manipulated in any way before it returns. If it is manipulated, it will call the stack check fail function, and then you as a user can decide how to implement the stack check fail functionality. So that could be just abort or something else of your preference. So this is something that we added typically for the IoT type of customers. Another thing is actually that was Hayden from Secure Things talking about in the first session with the Secure Boot Manager. And as I talked about with CStat and CRUN, we have the idea that we want to bring all these good things as close to the developer as possible. So that goes as well for the security part here. So to be able to work with this in a nice and easy way for the developer, you need to have these features also integrated into the workflow of the daily use. So this is not available yet, but it's something that we will release during early next year. So it will include the possibility to master your application, to do secure debugging, using a device with a secure bootloader, having a secure application, work with versioning rules and those kind of things in a secure way already from when you start develop your application. So this is to make it easier for the developer to work with these kind of features and have all those advanced features that Hayden talked about kind of run in the background when you do this from the application side. And by the way, these slides will be shared as far as I understand, so you should be able to get them from the organizers afterwards. Otherwise, you can just ping me afterwards as well, so if you need them. So another thing that ties into this a bit as well is functional safety. So of course, security is one important part here, and we've been talking today about the needs perhaps for regulations or standards within security. Maybe that is needed. I think that maybe as soon as the automotive industry start to think about that, then it probably will be regulations, because that's something they are really good at on the automotive side. So already for some time they've had a lot of focus on safety. So just to mention that our tools can also come with a safety package that gives also a certified version of the build tools, a safety manual on how to use these products in a safe way. So I think this also ties into security, although maybe you don't always have a requirement to conform to these standards. Using the information, for example, from the safety guide that we provide can, I think, for sure also help you to develop your application in a good way for security purposes. The last thing is the support services. So I think a big part of this when we talk about security and who is liable for anything, I think it's very important to consider this. So in our world, the customers usually compare our tools to maybe free tools that are available that you can use. So one key thing here is the possibility, of course, to be able to point to someone else. So the liability thing. So what we bring for you as a customer is the support and the possibility to come to us when there is an issue, and we will fix it for you. So just wanted to mention this, that we also provide this support services, of course, as part of the contract when you use our products. So to summarize, I've talked about the solutions from IAR when it comes to tools for embedded applications, compiler and debugger, two different tools for code quality control, CSTAT for static analysis, CRUN for runtime analysis, the stack protection features, as well as a bit about the new security concept here, and a bit about functional safety.